Hey guys, today I'm going to be explaining one of the fundamental concepts which we deal with in presenting data, and this is a frequency table. So I've gone out into my Melbourne market and I've made some observations on the old Big Mac, and I found the prices of Big Macs in my local suburbs, and I live in Melbourne. So I found that I could get them for $10, $5, $4, $8, $15, $6, $9, $2, $11 and $10, and these were all the prices of Big Macs. However unrealistic you think they might be, these were the real values which I observed in my local suburbs. So what we want to do right now is we just have this collection of data, right? So we want to arrange it into something which we can see which is nicer, which lets us read it with more simplicity, more ease, and extract more value from it. So this is something which Vecca likes to do a lot. They've done it on quite a few of their past exams. They did it last year, and I dare say quite safely that they will do it in a future exam. So typically when it comes to this type of question, they'll give us these data buckets. So in this instance we'll have price buckets, and we'll have a $0 to $4 bucket, a $5 to $9 bucket, a $10 to $14 bucket, and a $15+ bucket. So Vecca will usually give us these, and they'll ask us to place the data into this frequency table and calculate the relative frequencies. So the way you can do this is usually you draw up 3 different columns. So I'm drawing mine by hand, so it looks quite shoddy. But down here you'll have this extra row, and this is your sum of your frequency column. And this first column will be a tally column. This second column will be a frequency column, and this third column will be a percentage frequency column. So in Vecca exams you'll usually be given at least 2 of these columns, the frequency and percentage frequency column, and you'll just be asked to calculate those. I usually chuck in this tally column because it helps with working and it makes the process a little easier. So for those who are wondering, we've got 10 observations up here. And the way we bring our data into this frequencies table is we do this. We go through the data, and every time we have an observation lying in these buckets, we take that observation and we put it into its respective bucket. So this $10 observation would go down here, $5 would go in here, as it's 5 to 9, $4 would go in here, as it's 0 to 4, $8, and we just keep doing this until we had exhausted all of our observations, and we'd come out with our nice little data table. So this last figure is 10. Then, if we want to calculate our frequency, we just sum up the figures in our tally column. So here we would have 1, 2, frequency would be 2. And this frequency is literally just the amount of times that data in this bucket appeared in our sample. So this frequency of 2 was the observations of $4 and $2. So 5 to 9, 1, 2, 3, 4, 3, 1. Now for this sum of the frequency must equal our total observations. Because we had 10 observations, this sum of all of these, 2 plus 4 plus 3 plus 1, must equal 10, and we know that that does equal 10, and that's good. So that is a nice little check for in the exam. The tally column here, likewise, should be the same as this frequency column. If we just tally them up, we can see that it equals 10. So when we're calculating percentage frequency, what we were aiming to do is establish what percentage of the time observations in this bucket were captured in our sample. So the way we do that is we say, okay, we had 2 observations lying between 0 and 4, total of 2 observations. We had a total of 10 observations, 10. So the percentage time we observed observations in this 0 to 4 bucket is going to be 2 on 10 as a percent, which is 20%. For those of you not sure how to work this one out, it's 2 divided by 10 times by 100 is equal to 20%. Over here, we use the same maths. 4 on 10 equals 40%. Likewise, so the amount of times we had observations in this $10 to $14 bucket was 3. 3 on 10, 30%. And lastly, 1 on 10, 10%. So what we know is that if we had 10 observations here, our percentage frequency is going to be the sum of all of our percentages. So it's going to be 20% plus 40% plus 30% plus 10%, which equals 100%. So if in the exam, if you've got anything different to 100%, just means you've got a calculation error. Don't panic, just go back through your data set and find out where it is. So that's constructing a data table. Now once we've constructed a data table, Vector will ask us to do one of two things. This will usually be part A of a question. So I'll just bring out a nice purple ink. So this will usually be part A, and then they'll give us a part B of a question. Part B will be testing whether you can understand these tables. So the first way they'll test it is something called relative frequency. So relative frequency, we're dealing with these topics independently, or these buckets independently, sorry. And a way Vector will usually do that is they'll just ask you quite a standard question, something along the lines of, what percentage of time was a Big Mac but $0 to $4? So in order to answer this question, what we'll do is we'll come down to our table and we'll read the question carefully. We'll say what percentage of time. So we know we're not concerned with number, so we don't want frequency, rather we want percentage. So we know automatically we're dealing with this column. And they're asking us, was a Big Mac $0 to $4? So we'll deal with this data bucket over here, which is, whoops, sorry about that line, $0 to $4. Probably draw that a little better. No, I can't. $0 to $4. And then we'll just purely read off our table, $0 to $4, percentage frequency 20%. So we can say 20% of the time. A Big Mac cost between $0 to $4. So that's example 1, relative frequency. The other thing which we may be asked to do is something known as cumulative frequency. So this is where a few of the tricks come in and we get into doing a few more calculations. So cumulative frequency no longer deals with these buckets individually, rather it's asking us to accumulate them. So an example question for cumulative frequency will be something like, what percentage of time did a Big Mac cost more than $4? Sorry, more than $5. $5, say. And the way we'll answer this question is we'll go over our table. So we're concerned with data greater than $5. But if we look at our table, we don't have data, or we don't have a data category which is just greater than $5. So we're going to have to start adding some categories together. So if we come down here, we can see that we have $15 plus dollars. So anything greater than $15 will also be greater than $5. Likewise, anything greater than our lower bound for this category, $10, is also greater than $5. So we can say that these two categories will be included in our cumulative frequency. We can also then come down to this category here and say, okay, well, if the lower bound here is $5 and we're concerned with things more than $5, then we'll also include this category. If we come down to this last category and say, well, $0 to $4, if something's between $0 and $4, it's less than $5, so we're not going to be concerned with this category. So we're concerned with these categories from here downwards. So what we then do is we take our frequencies, our 4, our 3, and our 1, and we want to sum them together. So 4 and 3 and 1, which will give us 8. So that means 8 times out of our 10 observations, a Big Mac costs more than $5. So 8 out of 10 times, we're concerned with the percentage of time. So we want to convert this 8 out of 10 figure into a percentage. 8 out of 10 is equal to 0.8. We can do this on our calculator. And then if we want to convert this to a percentage, we'll say 0.8 times 100 gives us 80%. So we can say that 80% of the time, a Big Mac cost us more than $5. So these are probably the ways you'll be examined on it, and it's how to construct a frequency table. Remember to keep them neat when you're in the exam, and I look forward to seeing you in the next video. Bye guys.